Možemo da krenemo. So, we're going to start in a bit. We were waiting for Mirko, but he's going to join us, during the lecture. So, hi everyone. Thank you all for coming today. Today's format is a bit different, so I know you're all used to Goran. He is here online. Exactly. Goran is with us online, and we have hopefully other people joining. And today we're going to do something different. Instead of our usual lecture, we're going to do like a collective code review. We have Alexander and Petar with us here to start the discussion, but any of you can just raise a hand and chip in with these code reviews. So we had a few submissions, and to keep it kind of interesting, we've hidden them from our reviewers because they have they know some of these examples. So I'm gonna let Petar pick the color first. Okay, can you use the mic?
Green.
And yeah, okay. So green for Petar. So it's a submission by Alexander. He's here with us, and it's an implementation of a global variable. Maybe he can give some color to it.
Yeah. Okay. So hi everyone, my name is Alexander, and here's an example of an application code, so to speak. It's an old code from C++ 17 days. Like old C++ 17 is an old code already, and we have this distinction between like library code where everything should be perfect, like which you use all across the company, and this code is an application code. It was found in one of the dozens application, like someone wrote once. And the idea is that you kind of want a Bloomberg-style global variable where you put like some value, right? And you want to access it from all across your application code, like doesn't matter where. Okay, we don't have like performance requirements for it and stuff. And since it's an old code, it was kind of written poorly. So I find it an extremely useful code to review for new programmers like at our company and stuff, because there are a lot of things to discuss. There are a lot of easy things to find out, to correct, maybe to provide suggestions. And there may be some more advanced topics you can suggest on design how to write it. So as we can see, the purpose is to just have a global variable which you can assign the value. Yeah. Like maybe it's an aggregate or just a normal class, and just get a field, for example, if it's an aggregate, or just call it a member function of this class, but like it should be protected because we need to protect from overrides during, like, if it's a multi-threaded program, for example. And we can check the implementation. We can start from the data fields, around the. Yeah. So could maybe someone tell me what it's like? There is some library tool which is very similar to it, but there is some difference, right? Maybe someone knows. I would like to maybe people to be more active. So if someone knows a tool which does a similar tasks, maybe in Boost. You stand up and talk to the others. Yeah, if you. Okay. Okay, so I will not waste your time. It's kind of similar to synchronized value in Boost. It's effectively a data field, right, with the muters. But in this case, like the person who wrote it, they hard-coded a shared mutex because, like, okay, they learned the new fancy mutex which allows like for multiple reads without like blocking. It's pretty cool. But usually we don't really do it, right? So we try to maybe like type name it if we want like a thread local global. It's very nice thing. And kind of like this. So the review process like shows a lot of different stuff. I will not go through it because someone else as well should do it. And here I have like on the constructor a very little nice question mark because like it's like an open RPG world where you want to place a player somewhere and stuff because it doesn't matter where. Like there is a lot of very like questionable things, but we need to start from something, right? So maybe someone has something to tell about this construct. Yeah.
Maria, can you?
Doesn't make a lot of sense because you need two references, Steve, because this STD move will actually move a copy, right?
Not quite. Usually you have, for example, okay, since it's something I will say, it's a common pattern where you don't really care about a move cost because when you have a value like passed by a value, you can move this type, doesn't matter from the call side if it was copied or moved into the function. So if in case a user moves a value into this constructor, we'll just do two moves, right? But if it was copied, we will do a copy and then a move. It's usually easy when we want to allow R values, right?
So what you're saying is that this constructor will allow you to have, like, instead of having separate copy constructor and move constructor, you will have one that covers both.
It's not a move a copy constructor. The value is T, not a global.
Sorry.
Yeah, it's just a normal constructor with a value. So,
but wouldn't I'm sorry now again. Imagine that I want to have to move semantics. So I have this global variable and type which is STD vector, and I want completely avoid. But this will create as part of calling this global value with STD vector. It will create a copy of the vector, and then it will move that copy.
If from the call side we'll move a vector into this constructor, we will do two moves on the vector. So it's kind of quick. It's a lazy solution because the person who wrote it, they didn't want to make two constructors because
what would be the correct way of doing it?
Yeah, maybe a better solution would be to have two constructors, one for const ref and one for a value reference overload. And it would just avoid this double move case.
But the question is also if I call global variable with some right value, so with temporary value, wouldn't this create a copy of that value?
You cannot have global variable cannot be copyable or movable in this case, I think, because sorry, it's a shared mutex, so it can be copyable. For example, if you would have mutex, regular mutex, then it cannot be even movable. But this is not the point, I think. I think that this is just converting constructor from T to global variable. It's not the point about the global variable object itself.
Yeah, and regarding what you said, so somebody who's using this class can, so he can pay for both a copy and a move if it's written like this. But the thing is that the user can choose whether he wants to have it be a copy or a move. So if a user explicitly moves into this constructor, he's going to pay for two moves. If he doesn't explicitly move to the constructor, he's going to occur a copy plus a move. That's essential. Yes. Or recap.
It's pretty much quite the case from the Scott Myers like effective C++ book. You can read it like I think in the latest book it was pretty much covered like this. Okay, we will probably move next. So we will have kind of an in-place construction overload, which is a bit fishy, maybe a bit fishy.
Yeah, so it's quite an unstandard way to do it because so if you take a look at what it says, it essentially says that so we have first and then we have tail which has 3 dots. And there is a reason why most in-place constructors in the standard library have this STD in place, and that's to actually be able to distinguish the in-place constructor from the other constructors in the overload set. So the reason why somebody so if we were, so the way we really wanted to write this ideally was to have only args ... But the problem with that is that we would have a problem in the the overload set of constructors wouldn't know which one to choose, whether to choose the first one or the second one. I mean, it would choose one of them. It would usually choose the second one, which is something that's not fully clear. And somebody essentially took a shorthand solution here and made a distinction that we need to have more than one argument for this constructor. And the proper way to do it would be to follow the way it's done in the standard library, which would be to take in the in place as the first argument and then have args ... for other arguments. And
I'm sorry,
again,
can you go just a little bit up to for me to see the first constructor? But the first constructor is not a template constructor, so I don't think maybe in the overload set it will be this one that will be chosen, because the second candidate is more viable only if the first constructor is a template constructor as well, and then its universal reference is the one which is chosen. But in this case, you have a constructor which is not a template constructor; it's a template class. And
no, but the thing is that so if, for example, in the second one we didn't have first, if you were to remove it and only had args, what would happen is so the overload resolution has several steps. The first one would be to actually take a look at what consists of it. It would see a template, it would try to instantiate it. It would instantiate it with, for example, trfref, because it can do it, and that would be a better fit. And so the thing is that that cannot happen with this code, but there's a reason why. I would imagine that the person who was writing this firstly wrote the second constructor without explicitly having first and tail and only having args, and it didn't work. And there's a reason why it didn't work for them, and there's a reason why you have STD in place. So you both want to be explicit, which does make sense, but the other thing is you need to have a way to distinguish normal constructors from the in place one. So that's the reason why it's done like that in the
Yes, pretty much. Like it will work correctly, but as Peter correctly said, idiomatic solution would be to put this in place parameter into the constructor as well. It may work for this case, but idiomatic solution, we want to write our like same semantics classes the same as the standard does, because like it will be just confusing to not. Next, we will have the same calls to the members, for example, and we have like another, like it's a copy and place constructor, which is also kind of fish because maybe someone as well have something to tell about it. Who has an opinion? Like this is, it will copy, it will in place into the data member. It will in place the arguments, and it's using an call iterator. Yes, for that. It's cute, but it's maybe not the right thing to do, like in the idiomatic C++ code. Right? Maybe no one wants to say maybe something. Maybe a better idea would be, instead of the call operator, just call it in place. Like there's no reason to not.
Yeah, exactly. So when you're designing classes, you want to, naming stuff is really hard. And like the only thing that makes sense to do is to use standard names as much as you can. So in place would be the perfect name. In place with E. In place. Yeah. So yeah. So you want to be as close as you can be to the standard classes, because the user of your classes will expect that. Essentially, that's the main premise.
The others have anything with the rest of the example? Like any questions or any comments? Peter?
Again, we go to the same thing. So essentially, the thing that we are creating is it feels like an option. Sure, it's a global variable. It has this mutex. It's wrapping all of the methods, but you would expect that the API and the behavior of this class is similar to an API of an optional, and this clearly isn't similar to an optional. Like, sure, we do have some parts which are similar, so has value is there.
Yeah.
You have in place which is called differently, and then essentially what you tried, like with optional, you're able to access the methods of the underlying type through the like arrow operator, and somebody didn't want to think about it or wasn't aware of how to write it, and instead of that, they wanted to be able to call the underlying methods somehow, and they ended up sending like a member pointer, a function member pointer, which is really unstandard thing to do, I would say. So you always want to follow. So you firstly want to think about what's the thing that you're modeling, and you want to see whether there's something similar to that in the standard library, and if there is something similar, you want to copy its API, and that's the simplest way to do it. Like most of the types are copying API of something, like even an optional. Like when people were creating standard, they didn't really reimagine the world when they were creating an API for the optional. The API for the optional is almost identical to the pointer. But like you have dereferencing, you have arrow access. It feels like a pointer, as it should, because then writing generic code is much easier because everything is sharing an API.
Yeah, and on the topic of shared API is, as I said from the start, it's very similar to Boost synchronized value. And they do provide a protected access to member of the wrapped class. For example, when you do operator indirection operator, it tries to lock its mutex when you tries to call its members. So maybe for the user, it could be a better API if you would lock in the indirection operator instead. But generally, there's a bit of a difference. For example, it's not quite a stud optional, because like stud optional, we maybe could say that it's not the perfect API. Like it's a bit dated, it lacks a bit of tools which we will see in the future standards, I'm sure, but maybe it's not quite the right abstraction. Like I would even say that the indication that we don't use all the functions of optional, all the features of the API, means maybe optional is not the right abstraction in the first place. For example, you could maybe, since we have a lot of assets in the member function, for example, to access a variable, maybe a better abstraction would be if we expect that the global variable will be empty at some point, or we will replace it with empty, with something. Maybe it would be better to have a variant and provide a variant-like visitation. It tells a nice approach, but it all depends on the application, of course.
Okay. Thank you.
It's much.
Yeah, so we covered the global variable. So can you pick a color now?
Let's go with magenta.
This one?
Yes.
Okay. Exactly. So this one is from our internal code base. We as a team in our company decided to contribute with this example. So it's a compile time string, and we'll go through the example. But the reason why you need a class like this is you want to do some operations like string concatenation on strings that you want to pass as value parameters to a template. So that's the main use of this class. So you're writing a wrapper for something that's going to be passed as a template argument to a template, like a template value argument. Yeah, and the code kind of looks like this, and we can review it. So let's look at the, yeah. You cannot pass it as a value to a template parameter. You have a template, and it takes a string like a car star. Yeah, exactly. Yeah. Yeah, no. You can only use character strings. Yeah. Do you have a microphone?
Is it introduced? Is it introduced this that you did? Is it introduced with the STD string in C++ 23, 2026?
Oh, I don't know if you can use it. Do you know something? Maybe?
It's not.
Not yet. Okay.
Allegedly, would be allegedly at some point in the future, as the string would be able to be passed, but it's never gonna happen.
Yeah. So I don't think we have that example here, unfortunately, but we can maybe code something up. But this is the API of the class, right? You have the CT string, the compile time string, and you can do a concatenation of different string literals, and then that just works. So the main thing here is the concatenate thing, and here's some of the code that makes this work. So okay, here's the string itself, right? So maybe Peter can.
Yeah, so to start from the beginning, like the name is wrong. Like if it's a compile time string, it should be named compile time string, since like CT maybe meant something to the person who wrote it when he wrote it, but it's not really clear. So that's like for the start.
Okay. Other comments here?
Yeah, so we clearly can mark our default constructor as default. We don't need to provide explicit body.
Okay.
Maybe since it's a struct, it's kind of like we can have context for like member functions. I don't think it's a problem. I'm not really sure why they need to like explicitly like public variables and stuff. Length else is not a standard name to call the size of like a container. And effectively this compile time string, which is maybe more like a compile like string literal, maybe closer to like Qt does. And we could, for example, since it's a container, we can provide the container API as well, which is kind of nice. And I'm a bit, maybe I can cover a bit later on the design, because we can have a bit more than it is provided here as well.
It's quite minimal.
Yeah, it's super minimal, and maybe not, it's maybe super useful in one specific case, but we can really a bit expand on it and use in different places as well, because it makes sense to have like a static vector kind of thing, like to have a fixed size container, and you can as well pass it to templates. It's not a problem, but you maybe could have like not a full string. I think it would make sense, and you could concatenate it just as well, just the same as well, and maybe you could have an additional like function called trim to specific capacity, for example, instead, and it would maybe allow you to explore with different strategies for that as well.
Yeah. Can somebody comment on what is this maybe and why is it needed? Oh, yeah. Yeah. Does any? Why is this needed? Maybe could you even give us?
I'm sorry, I'm going to troll. The whole thing is not needed.
Okay.
So the whole code is not needed. The last time that we had a compile time string in our code base, we realized that in 3 of our third-party libraries that we depend on, all of those implemented their own compile time strings. And then we realized, okay, if we write a single compile time string in the future, then we are just insane because each modern C++ library implements it of its own. So the whole code is not needed, but for that one, for converting the char arrays to compile time strings.
Yeah. Okay. Then we have the concatenation method. And yeah, somebody wrote it like this, right? So if any of you got this as a pull request, what would the reaction? Did this have to be written this way?
No, because it passes strings like a reference to an array. I think it just I'm a bit like, for myself, I'm always confused because standard like how do you call it, C strings, they're like sometimes, for example, you can forange on them without this null character at the end. For example, you could use string view, actually maybe a bit better solution to that from some, but not for compile times, right?
No.
But I always forget, do you get like a null character when you like forange on a string array? Don't know.
Don't know.
So string literals are null terminated.
Yeah.
Like so this so all of this has so all of this is based on null termination as well.
Yeah.
I mean, like to comment the code above, like you do have lots of rollups, like
Yep.
it's simple rollups. You may be able to do something
Like this one. Right.
cleaner.
Yeah. But
the problem, I guess the reason why it wasn't done is because since everything needs to be compile time and you do need to trim everything for one character because of null termination, just nobody really wants to sit down and think about how you would need to, what you need to send to the algorithms to actually get them to work correctly. And since it's 3 lines,
yeah,
you just do it.
Basically, the point is you really don't want to be writing this yourself. And like Ivan said, there's a library that does this, that has this, and you know, use the library. Don't try to write this yourself because you know, it can hurt you, or hurt the people who browse your code base and need to read this at some point, or maybe even try to fix a bug.
Why do we need this function make city string?
Okay.
Usually, technically, I think guidelines don't require you to have a max city string, but in some cases you can use it when you don't want to use tat, tat. How do you pronounce it? It's like doesn't matter. You can just, you don't need to specify the length. You just need to deduce the length, and that's it.
Cool. Yeah.
So another thing to point out here is that, like, as was mentioned at the beginning, you could clearly see that the API is minimal since you're doing dotted data and stuff like that. Like if you really had the clean API, you would never do things like that.
Yeah.
You would never need to do things like this.
Yeah. Yep. So lots of API improvements and
yeah, this decal type lengths, it doesn't make sense to anyone who wrote like a lot of C++.
Yep.
you would probably like really just a context per member function and use it to size like even just global function as well.
Yeah, like we mentioned before, their standard library introduces a lot of API mechanisms, and when you're writing a type that resembles this, try to implement the entire API of the type you're trying to mimic. And here, obviously, the string or the string view would be something that you would want to mimic as close as possible.
Yeah. So also another thing to say, which we did mention a bit in the other example. So it's really important to understand what's the scope of usage of the code that you write. So when something is library code that's going to be used by a lot of people, it really needs to be on a different standard. So like, for example, this seems like something that is library code. So at least it needs to have documentation. Like for application code, you should have documentation as well. But like I can understand not having it, but like for things that is going to end up being used with lots of people, it really does need to have a different standard of both documentation and API design.
Yeah, and the documentation wasn't removed. This is copied as is.
Else, just a little note on maintainability, like long term, namespace detail. It's a bit of an anti-pattern actually, like from exactly the name detail.
Yeah.
Because if you have a lot of like thousands of these fancy, cool classes with the detail namespaces, they will inevitably crash. Like it's pretty much grand. Like, okay, maybe make city string will not, like very unlikely you will see it, but you will often have like some additional helper, like concepts, like traits, maybe, which are used for the specific like type. And across all the code base, it's just easier to make, instead of detail, like /city string or something like that, but not from the uppercase, like make it lowercase. Because
And how about just do this, right? Yes, no?
Lose the fact that that's another interesting thing. So what is mentioned earlier, like you want the API to have documentation and everything. Like if something is an implementation detail, then again that, at least from my point of view, doesn't require the same level of rigor and people going and looking at it and like removing the detail, remove that information. So if you were to remove it, at least you need to have some kind of comment saying that, and it's always better to have it be code than comment if possible.
Okay. Any other questions? No? Yeah, okay, then we can go to the next example. And Mirko, you get to pick the color now. So we've had this one, and we had this one.
Yeah, blue, of course.
Blue, okay. So this is the stupid question, actually. So it was I got it from a friend, who used it as an interview question in his company. So this type of code is really good if you're interviewing for a company and they have this guy interviewing you. Otherwise, probably not a lot of useful things you can find, but people like to look and to interview with other people with code like this. So the skill of reading such a code and giving comments on it can be useful in those scenarios. Cool. This is not Godbolt. So, okay, this is C, and the interview goes like this. It's tell me your opinion on this code, and you can go line by line, and then we can comment on it a bit. So I'm expecting a lot of. Mirko can start like with his first observation, and then we can continue with everyone else, right?
Yeah, my first observation was that I would not like to work with a guy that has this kind of test.
Yeah.
Because there's a lot of things that are bad in this code, but I don't want to search, I don't want to find them. It's just bad code. You know, if somebody didn't put some parentheses or something, it's or like in line 11 or I don't know if, or not 11, later in line 23.
Yeah, so there's this thing. I don't know if you caught it. So
I don't want to be the one that searches that stuff. You know, I am expecting for the code editor to find me those things that I will miss. And there is some assert or return macro that doesn't make sense for me with the name for it, you know, and there is, you know, there are some logic stuff inside that, you know, the program, if you go, you know, line by line and inspect it, you will find some logic issues with it, but I really don't want to look at this kind of code, and that's my...
Yeah.
Okay, first is there is a malloc, but malloc is generally the address is always aligned to 4, so at least for consolidated bit architectures. So this whole for loop is probably not needed. And the second thing, I saw that in assert, you see that you read file, but asserts don't necessarily have to exist. So this reading file will, if asserts are disabled, this reading file will will compile to nothing.
Oh, but this macro doesn't call assert, right?
It doesn't call it assert, but it's called assert. So I guess
Oh, yeah,
at
yeah.
that point it can be undefined.
There is an issue with the macro itself. Does anybody see the issue in the macro itself?
It's a classic.
It's a classic issue, right? If you ever had to write a macro, you come to this. So you have this condition. It's a variable that you're trying, like a macro variable, and you're using it here, right? And saying if it's not.
You need to put it in braces.
Yeah, you need to put it in braces, exactly. So you need to put this in braces because of this thing here, right? Because this not will take precedence of over the greater than, and then you will not the I, and then compare that to greater than 2, right? So this is a classic macro issue. Also, there's one more thing, and that's this trailing slash. This picks up the next line. Fortunately, here it's an empty line, but usually macros, you know, the last line doesn't have this trailing slash. If we were to have some code here, it would get picked up by the macro itself.
Yeah. Also, like the beautiful thing that Mirko somewhat mentioned is so just getting this code and running it through Clang format or any of the formatting tool would drastically help with seeing problems.
Yeah.
So that's probably the like. So if you're working with multiple people and not working alone, and even if you're working alone, like the first thing that everybody should do is define what's their standard for writing code and how it looks, and then have a tool just do it.
Yeah.
And that just gets rid of multiple different problems that people just don't want to think about.
Yeah.
What actually happens in line 8? Like, because there's like these 2 comma.
Okay.
So what does actually happen? I'm not sure in line 8, like, because there's 2 variables.
Yep.
And then you malloc, and then you cast it to int. But there's no 2 mallocs, right? Or
No.
is there? No.
No.
Okay. Because
So
I mean, I never do the comma separated values.
yeah, no. So this gets the I gets default initialized. The PTR variable gets I mean not default. It's uninitialized. The I variable is uninitialized, and then the PTR value gets initialized by malloc. But there's another thing that's bad here, and that you're casting malloc to int.
And of course, naming is terrible.
Yeah.
PTR.
Malloc returns a 60-bit pointer and
Yeah.
cast it to int.
Yeah.
It should be uint pointer underscore t.
Yeah. If you need that, right? But you don't.
Just some news from the C++ community. Using uninitialized variables is no longer undefined behavior.
Oh.
It's now called erroneous behavior. And it has a different semantic.
Okay, cool. Hopefully that gets us to bigger safety, which was one of the major things that got attention on the last beacon, right?
It's quite interesting how everybody was talking about how they don't really see safety as important, but let's talk about it. Right?
Yeah.
We had multiple talks.
Yeah, there are a bunch of stuff here. Like there's this thing here that's also like a common mistake that you see. That's an off by one, but here it's actually not an off by one because we allocated 1,000 bytes with malloc, and then we were iterating with an int pointer, and there's an issue there. So and then we are iterating on things that are forgot to close file, lots of small things like this, but this is definitely not a code that anybody should write. It's just cool to comment on. And again, this is C code, and using modern C++ practices would, you never write things like this, right? So that helps a lot with a lot of common gotchas that this code was written to, sift through.
Yeah, like there's so many things. Like even in the if you have and, which explicitly sum of the rows instead of two ands and stuff.
Yeah.
There's, there is a comparison with, the guys, workers, that use drills and try to drill holes somewhere and stuff. And if we look at this code, it's like asking the driller in what way some drill can be broken. No, it's for me it doesn't make sense.
Yeah.
It's bad code, and that's it.
Yeah.
This is not real code.
No, this is made as an interview question. Yeah. Okay, so we have blue, and now we have a choice between. So what next? We have yellow, purple, and red. So yellow. I heard yellow. Let's do yellow. So this was submitted by Maria. She's here in the audience. And it's her coursework, like from a course at the university. And I think to not show the entire code, she gave us only some things, but the main thing to focus is this file here. And let's see if we can.
What's the idea behind why is it this code?
Can you take the mic?
Yeah, it's memory allocator for kernel, and it's continual allocation with, I think, first fit algorithm. And that's it. I did this 2 or 3 years ago, so it's mainly here because none of you wanted to submit anything, so shame on you.
Thank you, Maria, for
some hint. I got minus points for not implementing this like a singleton. So that's something. But because it's
a design pattern.
Yeah. We didn't learn design patterns then. No, I use static variables.
Oh yeah, H file. Sorry. Yep.
So I have a question. Like did the compiler that you were using, did it have namespaces?
Yes, it did.
Yes, it is. So this was a RISC-V implement. Yeah, this was a kernel for RISC-V. No, a custom kernel. So it's a part of a course as a yeah, electrical engineering in Belgrade. It was 2 years ago.
The first generation that did it on RISC-V.
So you see everything. Oh,
Virtual machine.
yeah. So Peter, you had a question?
Yes, so like I remember when I was like doing something similar at faculty, and like we were using like C++ 98. That's the newest one.
No, this is
So and like it didn't have namespaces. So at that point, you had people using classes to simulate namespaces, which this seems similar to.
Yeah. But so what was the reason? Maybe can anybody guess why the suggestion of implementing this as a singleton could have been design-wise at least better, and not have all the member variables in the class as static?
Yes, I agree, but we learned design patterns in the next year, so.
Yeah. So can you?
Again, devil's advocate here. Let's try to defend this not being a singleton.
Yep.
If we had several allocators, all are defined as classes with static stuff inside, then they can be used as template parameters for something that uses an allocator. If this was a namespace, it wouldn't be possible. If it was a singleton, it wouldn't be possible.
Yeah. Can I show the implementation of kmalloc? Sorry.
Yeah, I'll just say one more thing. Like, and it really has nothing to do with the code. Like you're clearly using two different like case styles for naming the functions. Yeah, and that probably happened because a part of the class was given to you, and the other part was given by you.
So let's see. We're looking through it, right? kmalloc, you asked for the implementation, and it's here. And
Honestly, no.
so we have
Don't, I'm sorry.
this calls memmalloc, and then memmalloc calls try to allocate fragments of a size, and then here is the implementation.
Well, that didn't work for a very long time, and init memory is like I'm checking is it initialized, and if it is, I just pass. I don't do the rest of the logic. So I guess it was quick fix and it worked, and I was like, good enough. Yeah. No, it's not.
Yeah, and also like this whole block, right, is huge. So this is something that you do at university, but like Ivita said, one of the suggestions would be like, okay, just break this into several functions maybe. And one thing, there's one way that you can automate checks like this, and it would be to introduce a cyclomatic complexity check or cyclomatic complexity analyzer for your code, and then it would also scream at you to refactor this.
That's a fun question. So do people know what cyclomatic complexity is and what's the cyclomatic complexity of this function?
Oh, yeah.
So cyclomatic complexity, it's a measure of code complexity, and it's a number of nested ifs or whiles or for loops. I'm not sure exactly. But when you have a lot of it, actually your code is quite unreadable. So you should think about how you can make it a bit smaller.
Yeah, so to be a bit more precise, it's the number of different execution paths through the code. Yeah, ifs and fors and loops are the things that introduce different execution paths. And the problem with cyclomatic complexity is the larger it is, in order to validate the code is correct, you really need to go through all of the paths. And if it's 10, then you essentially are reading 10 different functions at the point. And like the reason why why splitting things into function actually helps in reducing cyclomatic complexity, because like if you were just going to like stupidly cut it down, you would end up with reverse code. Like the only way that's meaningfully reduces cyclomatic complexity is if you're combating
Say that, sorry.
Yeah, so the thing is that so you have a combinatorial explosions when you have multiple ifs and fors. What happens is that the number of different execution paths is scaling combinatorically, and you need to extract this combinatorial explosion from the code in order to actually make it.
Yeah, exactly. So we can go. It's a pretty big file, but like you said, basic things like this can drastically improve.
Yeah, just to put my few cents in
Yeah.
here. Like, for example, when you start to argue about like complexity of the code and you like pull up a number, I think at this point you already lost. You shouldn't get to this point, like never.
Yeah.
Like it's always like just a futile effort, just rewrite everything.
Yeah.
Then this code is old, but just like it's not a complete problem because a lot of old code looks like that. Like it's okay. But like there's a lot of things which you could pull out from the modern C++, like null pointers and stuff, like C student for types instead of a global namespace and all of that. You can port it to a modern C++, it's not a problem. Static member function as well, it's kind of used in Bloomberg, for example. They use a lot of stuff like that because in namespace, you can add functions in different files, but if you use a class and add static functions, you will never be able to add a new function into this namespace like from another file. So it's kind of like a feature. Yeah. It kind of like this.
Yeah.
But you need the same style for everything. But like if you work in a company, you will have it.
You can do this.
Well, just thinking about it naively, I'm thinking, putting things into functions doesn't really reduce the complexity in itself. Like you're just moving the code and you're reusing the code, but
Yeah.
you are.
So the fact that you had to, there are two things, right? There's the cyclomatic complexity is measured on a level of a function. So it does reduce the cyclomatic complexity of the function, but why does it reduce the complexity of the code in a more informal sense? Is that you had to think and name things, and when you name things, it helps people digest the code more easily, right? So when you have large blocks like this, people usually, have this habit of leaving comments above ifs, right? Okay, this is an if where I check that, right? Why don't you extract it into a function then and give it a name that says the same thing that your comment says, right?
Okay, so
that
implementing complexity is not just the number of branches you can take in a code. It's also
it's a number of branches in a function, but it's only measured in a function. So if you were to take this into another function and just call the function here, the number, the metric will go down, right? But I'm talking more of a complexity in a broader sense, helping you understand code.
all right.
Can you scroll to 198?
198. 198, yeah.
I've seen something that is my pet peeve, which I did punish my students for. If P return true, else return false. In this case, if P return false, then return true, and then the P is a negation of current equals 0. So it would be a little bit easier.
Yeah, definitely.
But this is something that I really love to see in students' code.
Yeah. Lots of feedback, lots of feedback.
Okay, I have another question.
Oh, yeah.
Would the early returns, would that decrease complexity or not?
Yeah, definitely.
Yes. Okay.
Sorry.
Actually, I have.
Yes, so early returns don't necessarily reduce implemented complexity, but they do increase readability of the code.
Yeah.
That's
And also they can indicate what, for example, you can filter out for in a for loop. If you have an early return, that usually means that maybe some of the objects you are iterating through, you could filter out before entering the for loop itself, for example. And
it's like the whole premise of tackling complexity. It's quite interesting. Like in order to so the only way to tackle it is by having a shared vocabulary. Like if none of us had a shared vocabulary, like me using some words would mean nothing to nobody. So the value comes from having a group of people who have shared knowledge about concepts, and then using those things is the thing that actually brings value. Like imagine having a code base where all the standard algorithms had different obscure names. It really wouldn't help you much if somebody is using functions.
Yeah. Okay. 2 more to go. There's a purple one, there's a red one. Which one do you choose? Purple. Okay, it's a ring buffer. So this one should be fairly quick. We've seen ring buffers in our last talk. Yeah. Yeah. So Mirko, can you guide us through this code a bit?
Yeah, we have 2 versions. We have ring buffer and push only ring buffer.
Yeah.
Ring buffer is the basic implementation.
This is the ring buffer.
The idea is, the last time we met here was, the topic was, touching a ring buffer, implementation of ring buffer. This was just our trying that. There is a container which holds elements. We have 2 pointers. You can push elements inside. You can pop elements from the back. Basically, if you fill it up, you would push the last element out, and that's it.
Yeah. So
we tried to make it iterable in a way, using standard iterators. So that is this whole stuff in front. And that is all that we wanted from the API besides the basic stuff of push and pop.
Yeah. So also there's a note here, right? There's this template parameter that allows you to choose your own container if you wanted to use a vector or another type of container. With the array interface, you can yeah.
And that's
Oh yeah. We have another thing that's called stat, like a vector that implements this. So
yes. So the interesting thing is, so you have a container and as the array. The problem is that you don't know what the subset of the API that you're using. So having some kind of concept that actually specifies what's the actual usage of the type depending on would be useful here.
Yeah. Also, like all of these types here, right? There's a reason they are here, right?
Yes. So all of them are require. It all comes down to trying to be similar to existing APIs, and these are some of the requirements for you to be a.
Yeah. So that's why we see mixed case usage, right? You have Pascal case here, and you have Snake case here, and that's because some of the standard library concepts.
It's because someone choose a code base style sheet wrong.
Yeah.
From the first. My like.
Okay.
I cheat a bit. Could you like in the beginning?
Okay.
So I have seen this code before.
Yeah.
And the thing that confuses me a bit is that you require a container, okay, but you require std size. Like there are some continuous containers which may have a signed type. It shouldn't be a problem, I think, because I tried to check like what you use on the size, and these operators should be signed safe, I think. The second thing is that you do require a contiguous container because in the iterator basis you can RNG buffer iterator, you hard code a trait for continuous container. So random access iterator. So a better idea would be to static assert that this container which you pass is a container which can support this iterator.
Yeah. And that will also probably spit out much better the compiler error if you were serious.
The static assert is an old school style, so a better way would be, of course, to use the concept in there. So. Yeah.
You know what you show with the module stuff. Yeah, module capacity.
Module capacity. Yeah.
So you can avoid module with start. Just check if you're over the graph, you graph around and just reinitialize to 0 and push the.
Yes, so that's something that's not fully clear here is that it is module capacity, but the capacity is always it's always multiple
power of 2.
That indication is not necessary. Yes, module is fast and you do it the power of 2 and it's a compiler cost. But if I wrap around 0,
yeah, so if you were to benchmark it, having an if there, it introduces jitter and it's slower than yeah. So the fact that you have that if the problem is that once you're wrapping around, you have the if that's going to be assumed with the wrong branch, and that introduces jitter. Yeah, of course. The thing is that comparing the case when you're wrapping around and when you're not, you have additional latency because the compiler is not expecting the if to go that path. And that jitter is something that you want to avoid in some use cases. And again, more honest thing here, if you really are focused on performance, would be to actually static assert that n is a power of 2,
Yeah.
and then all of this is fine, it makes sense. If you're not doing it as you or not, you have like using a model of not a power of 2 is a really slow operation, and doing an if is a better choice. Even going with the with the branch misprediction, it's still faster than doing the model operator. If it were not a power of 2.
Yeah, and some of the interesting decisions here is also like a lot of these methods are implementing the standard library APIs, which is something that we suggested for the previous class, right? So there's a lot of these. You have reference, and then you can have the const versions of that. Yeah, hopefully we get an easier way to write this, not copy the code twice, and have a standard way of specifying it. I would like this to be the same for the const and non-const. Just
Yeah, that's something that you will be able to somewhat reducing this. The other thing to note with this example is that so you have 3 classes. So you have ring buffer and push on ring buffer, which are quite similar. Like most of the implementation is identical, and it's always a pity when you need to duplicate the code, especially parts that are a bit more complex.
Okay, so could you have used maybe a base class for this?
I mean, I wouldn't. I would rather copy it than you.
Yeah. Okay.
The thing is, this is both implementations are self-contained. With the base class, I would have to look at 2 files.
Okay, yeah, sure.
How about those comments that they are?
Yeah.
One more moment, when you use just a general exception, stood exception, like how to properly support. If you want to support exception, use proper exception, because for these types of checks, you need not to use runtime error, but out of bounds error, a standard one, because it's called in the appropriate member functions in vector and other similar member functions.
Yeah. Is there any part of the code that anybody wants to pay particular attention to? So can you maybe explain the iterate basis base and why does that exist, and how does that get used in the ring buffer?
No.
Okay. Anybody else? Do you know why do you use this? And no?
Well, let's look at the code if we really want to.
Yeah. No, but how do you use this class, right? That's like the question. How do you use the iterator base class? Well, why do you write it, and what does it help?
Yes, you clearly didn't want to write 2 different iterators, the basic iterator and the constant iterator, and then you created something templated in order to have one implementation.
Yeah, okay.
It's a common implementation of iterators that you need a non-const and a const like underlying type. So you usually, it's kind of hard to propagate like from the const and non-const member variables to a proper iterator. So you need a proper type, but this type as well, it can be like, since it's copied, it can be like const iterator. So it need to have a separate type. So that's why there are different solutions people do it, like they sometimes just inside the same class and stuff, but like this solution is okay as well, where you just pass different underlying type to the same type of trait. It's pretty much idiomatic. Yes.
Yeah. Okay. Okay. Anybody want to comment anything else? Can you get the mic? Can you get the mic just for the comment, because it's really okay. Yeah. Okay. Then, if you were paying close attention, we also have one more left. But since I know that one, and I know that is a big one, right? And it's a simplex method, and oh, why doesn't this go to the hyperlink? It's broken, maybe for a reason, right? Because it's huge. So yeah, it doesn't work again. Link. No. Yeah. Go to. Yeah. Okay. It's an implementation of a simplex method. It's a mathematical. Yeah. And because it's huge and we don't know much about it, it was a last-minute submission, and it would take a lot of time to. The author is Sergey, who left. Yeah, exactly. No. Yeah. But we can maybe go through this as a homework, right? Because yeah. So a bit of background on this is it was used by him to show it to other people in his community. So I think, and he didn't like it. It would be perfectly fine to have this. Okay. Yeah. 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 Probably that's probably what. Yeah. Like there are things. Yeah. Yeah. Also, like variable names, but this is quite common in scientific, or this is a style that you'll find in scientific communities. Like if you go through any scientific code, or if you go to like any competitive programming type of code, this is quite normal to have these blocks of ij, j0, I0 variables where you have one letter variables and you use them a lot. So rewriting this to a modern C++ could benefit from it, but a lot of this type of code looks like this, right?
Actually, I have like a code example.
It's like almost an hour and a half, and we should probably leave it here, right? And if you guys liked it, we can do this another time. And for that one, we have Peter's one submission, but hopefully we get a lot more submission from you guys, so we can go through code together like this and learn things. So thank you everybody who submitted code. Thank you to Petar, Alexander, and Mirko. Yeah. So for everybody who's here, you have drinks in the fridge, and then help yourself. For everybody online, we leave you guys. Bye bye.
Bravo, uživajte, pozdrav.